Okay, so let's use this theorem we just proved to analyze the order accuracy of some Adams-Bashforth methods. Okay, so so we have the Adams-Bashforth method. It's like with two steps, which is of the form yn plus 2 minus yn is equal to h times f evaluated at, well, 3 over 2 f evaluated at yn plus 1 tn plus 1 minus 1/2 f evaluated at yn tn. And then there's the three-step Adams-Bashforth method, which looks like yn plus 3 minus yn plus 2 is equal to h multiplied into 23 over 12 f at yn plus 2 tn plus 2 minus 4/3 f evaluated at yn plus 1 tn plus 1 plus 5/12 f evaluated at yn tn. Okay, and so I've written this in the following way because they have they're structured in this canonical representation for a multi-step method, which is the sum from m equals 0 to s of am yn plus m is equal to h times f sort of multiplied into the bm coefficients. Okay, all right, and as you recall, there are two characteristic polynomials which are associated with the am and bm coefficients. There is rho of m, which is expressed in terms of the am coefficients. And then there's sigma, okay, which is expressed in terms of the bm coefficients. Okay, and then the result we proved previously was that to obtain or determine the order of the method, we look at the following combination of rho omega minus sigma, or rho w sigma w natural log of w. And you want this to be some constant multiplied by w minus 1 to the p plus first power plus something which is big O of w minus 1 to the p plus second power. Okay, so this is these are the two methods we're going to apply it to. This is the general form of the multi-step method. These are the characteristic polynomials, and then this is the order condition expressed in terms of the two characteristic polynomials. So let's see how you go about applying this result to these two examples. Okay, so for Adams-Bashforth 2, right, rho of w is going to be, sorry, that's a yn plus 1 here. Okay, so it's going to be w squared minus w, and then sigma of w is going to be 3 over 2w minus 1/2. Okay, and to simplify matters, it's like when you evaluate this expression, because you want the series to end up being in powers of w minus 1, I introduce a new variable c, which is w minus 1, right, which more or less means that w is equal to 1 plus c. So I'm going to look at a series that's like in terms of c instead, and I'm going to write down rho of 1 plus c, right, minus sigma 1 plus c natural log of 1 plus c, and then this is going to be a series expansion in c, which is going to give me the expression which I want. All right, so let's see what you get here. All right, so rho is w squared minus w. I'm writing down w as 1 plus c. So this is 1 plus c squared minus 1 plus c. Right, okay, minus sigma, which is 3 over 2, 1 plus c minus 1/2. All right, and then I take a series expansion for the natural log of 1 plus c, and so this is particularly useful because 1 plus c, it's like natural log has a very nice series expansion, right? So it's just given by c minus 1/2 c squared plus 1/3 c cubed, and so on. Okay, so let's see what happens. This is okay, c squared plus 2 c plus 1 minus 1 minus c. All right, so that's the first term, right? Minus 3 over 2 plus 3 over 2 c minus 1/2 c minus 1/2 c squared plus 1/3 c cubed, and so on. So you can expand all this out. Let me sort of just do one more step here. So this is c squared plus c minus 1 plus 3 over 2 c minus 1/2 c squared plus 1/3 c cubed in higher order terms. Okay, so this is going to be 5 over 12 c cubed plus something which is big O of c to the 4th. All right, and then of course c is w minus 1, so it's exactly the form which we want. So reading it off, it's like you can see that p is equal to 2 for the Adams-Bashforth method with 2 steps, right, which is exactly what you expect. Okay, so that's the Adams-Bashforth method with 2 steps. So let's see what happens with Adams-Bashforth 3. Okay, so again, you read off, it's like what the rho is. Rho of w is w cubed minus w squared. Sigma of w is equal to 223 over 12 w squared minus 4/3 w plus 5 over 12. All right, and then we want to look at rho of 1 plus c minus sigma 1 plus c natural log of 1 plus c. Okay, so this is 1 plus c cubed minus 1 plus c squared minus okay, 23 over 12, 1 plus c squared minus 4/3 1 plus c plus 5 over 12 multiplied into the series expansion for the natural log of 1 plus c, which is again c minus 1/2 c squared plus 1/3 c cubed minus 1/4 c to the 4th plus higher order terms. Okay, so you can simplify this a little bit further. This gives me c cubed plus 2 c squared plus c minus 1 plus 5 over 2 c plus 23 over 12 c squared, again multiplied into the series expansion for the natural log of 1 plus c. All right, and then you look for the leading order error term, and then this is going to be 3 over 8 cos c to the 4th plus big O of cos c to the 5. Okay, and so that tells you that p plus 1 is equal to 4. Okay, or that the order of the method is equal to 3. Okay, so that's again consistent with what you know about Adams-Bashforth methods. So if you have an Adams-Bashforth method with S steps, then it's going to be order S. Okay, so the Adams-Bashforth method with 3 steps is order 3, which is what we see here. Okay, so let me stop now.